Okay, today we're going to be talking about projectile motion. Projectile motion is anything that refers to a situation where an object is thrown, launched, or dropped. Gravity is our key factor here. You'll see it given by negative 16t squared or negative 4.9 t squared. It's feet when it's in negative 16 and it's meters when it's negative 4.9. Most functions will be given in a format similar to this, where it's h of t equals negative 16t squared plus 64t plus 5, where gravity is the first one, your initial velocity is the middle one that has just a t, and your starting height, or the y-intercept, is the 5, or the number that does not have a letter on it. Okay? And t in this place typically stands for time. Okay? So now let's look at a video that allows us to see what some parabolas are. So now, taking a look at the blob, which is where you have somebody jump onto a big mat and launch somebody else on the other side of it, let's see how that represents a quadratic function, and we'll identify all the parts. Okay? So, first, when the guy is on the blob, this is our y-intercept, because the water represents our x-axis. Okay, and the vertical, how high he goes, is our y-axis. And so you can see he's not exactly on the water. He's elevated ever so slightly. So that would be his starting height. Or that number 5 that was in that previous question, that would be where the y-intercept would be. So where did he start? That's the y-intercept. Okay? Then you'll see he'll gradually get launched higher and higher until he reaches his highest point, his max height, okay, also known as our vertex. Okay? In this, he'll actually be going up and down at 0 miles per hour or 0 feet per second, depending on what your speeds are measured in. Okay? Then he'll start coming back down, okay, where he'll land in the water, and the water is our solutions, our roots, our zeros, our x-intercepts, the ground, okay? All those things that we've been talking about, that when we're trying to solve a quadratic function, when we set it equal to 0, that's what you're finding, how long it took for it to hit the ground. Okay? There are only 4 types of questions when you get a projectile motion question. And if you can learn to identify these 4 types of questions that they're going to ask you, then you'll be great at answering projectile motion questions, because you already know all the parts already. First, they'll ask you, what's the starting height? Well, that's just the c in the ax squared plus bx plus c, or that number that does not have a letter on it. It'll ask you about the minimum or maximum height, and we just saw in that previous picture that that's the vertex. The time of the max is given by that function that little formula that we found previously, x equals negative b over 2a, or the opposite of b divided by 2a. The max height itself is when you plug in that number, and so the formula gives you the time, and then when you plug in the time, it'll give you the height. The next thing they'll ask you is, when did the object hit the ground or hit the water? And we saw that, and that's when we would solve by factoring. The ground and the water represent those zeros, those roots, those solutions, the x-intercepts that we've been talking about before. And then last but not least, it'll ask for what is the height after a given amount of time. So they would say, how high is he after 2 seconds? Or if they threw the ball 3 seconds later, how high would it be? Okay? And to do this, you would just plug in that time into the equation and solve. Very similar to what you would do to find the max height. You take that time that you found, or that x equals number, and you would plug it in and find what the y is. And that, my friends, is all you have to do. The hardest thing in these problems is figuring out what the question is asking for. It's asking for one of these four things, so that's what you need to look for. You need to look for your keywords. Is it talking about a maximum, a minimum, a vertex? Okay. When did he reach the top, or when did he reach the bottom? That's your vertex. Think negative b over 2a, or opposite of b over 2a. When was his initial height? Or if you're talking about a baseball getting hit, at what height was it when it hit the bat? Well, when he hit it, that's the initial time that the ball started going up. Okay? Things like that. Those are going to be your keywords for y-intercept. The ground, the water, when it hits the road, or something like that, indicating that flat surface at the bottom, at the end of the drop. That's when you're going to talk about solving it, finding your x-intercepts, your zeros, your roots, the solutions. Okay? So that pretty much sums up the information about projectile motion. Next is just solving it like you've been solving before. Thank you for watching my video, and keep watching.